Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios, and what I have for you today is the answer to a question: should you avoid debugging? Particularly, should you avoid debugging in 2024? The reason for asking this question is because I see people who are confused about this assertion. So there's an assertion circulating, particularly the extreme programming practitioners, who say, look, I haven't used the debugger in years, or maybe once a year. And that's something I have experienced as well. But for somebody who doesn't know all the other things that come in play in order to enable this, it sounds like a very confusing thing. Like, how would you even avoid debugging? If a bug comes, what do you do? And how do you get around introducing bugs and so on? So this is why I decided to give this a tour. It's also very interesting to me. It's a very interesting topic because you'll see I have some history with debugging. I was fairly good at debugging when I still used to do that before I started writing a lot of tests. And I had a particular method of debugging, which we'll discuss in a little bit. And I found debugging really, really fun. But turns out not the best use of your time. So this is what we'll be discussing today. Okay, so the question is, should you avoid debugging? And let's start as usual with the TLDR. The conclusion to this will be that if you have good, fast, small tests that cover enough of your code, they reduce the need for debugging to almost zero. And we say almost zero because some bugs will escape. And those bugs are caught by exploratory testing. But then what do you do when you get the bug and you need to fix it? How do you do it without a debugger? Well, there is a test first approach. You first write a test that proves that the bug is there. You then change the test to show the desired behavior. The test will fail now, and then you implement the code. You change the code so that the test doesn't fail anymore, and then you refactor. And another thing that you need to take into account is that a debugging session is an automated test that is not saved. Okay, and by the way, there are still good uses for debuggers, and we'll talk about all this in a minute. But if you found this useful, thank you for watching. Leave us a comment, ask more questions, and now let's go into more details. So we'll talk a little bit about the fundamentals of debugging. We'll talk about tests and debugging. We'll talk about when debuggers are actually useful, and about what I'm calling the HouseMD method of debugging, which is actually something that I have been using before HouseMD came out, but I'm a big fan of that show. And also, it's actually not the HouseMD method of debugging, it's differential diagnosis, but we'll talk about this in a moment. First of all, let's clarify a few things because I've seen some confusion around this as well. What do we talk about when we talk about debugging? Well, when we talk about debugging, we talk about the process of investigating and fixing a bug. That does not necessarily imply using a debugger that you attach to the process and step into and step out and visualize variables and so on. But it can. And debuggers are an incredibly valuable tool, extremely useful, which is why I think they are so popular still. I mean, if debuggers weren't that useful, we would probably write a lot more tests because that's the only other way we can deal with this, or make our code much cleaner. And so debugger helps, but it's not mandatory. Another thing about debuggers, honestly, the things that you can do with debugging today are almost mind-blowing. You can actually, and I think Microsoft is the leader in this with Visual Studio, the fact that you can step into processes that run on different machines. And yeah, this is possible. If you have the source code, you can basically step into and see what's going on the client side, on the server side. It is amazing. It's amazing how far they've gone. So honestly, it's one of the best tools we have. But now I'm gonna tell you, you don't need those, and you can get rid of them. And despite them being very powerful, and despite the feeling of finding the bug being so great when you're doing this, using a debugger and the debugging session, it's still not the best way of debugging, and not the best way of, well, preventing bugs. It's a more boring one, but hey, boring is good when it comes to software. So a debugger helps, but is non-mandatory. And the reason I'm saying this is that sometimes you'll see people saying that I haven't debugged in years, but most often what happens in extreme programming and what practitioners say is I haven't touched a debugger in years, because some bugs will escape no matter how well you write your tests and you structure and so on. There are some weird cases that a good tester will catch in exploratory phases, and those things need to be taken into account. So you'll still get bugs, but the rate of bugs will go really low once you have automated tests that are well written. And that's a big caveat, because I've seen automated tests that are not as good. Okay, so this leads us into a discussion about tests and debugging. So first of all, if your code base is covered with tests that are small, fast, and that you can trust, you will rarely debug. Because here's what will happen. Let's say you missed a test. Okay, and somebody finds a bug. What you'll do is you'll look through the list of tests and you'll figure out, oh, we're actually missing this case. I need to write a new test. You'll write a new test and then use the test to fix the bug. And yeah, this is technically debugging using tests. Okay, but you will not use a debugger. Okay, so you see, I can understand why people are confused. So you'll rarely use a debugger if your code base is covered with tests that are small, fast, and that you trust. But even then, some bugs escape. They need the exploratory testing. And then we can use this method of test first debugging, which is basically, instead of attaching a debugger and going through and figuring out what's going wrong, write a test that proves the bug exists. So how do you do that? Well, when you get the bug description, you have the expectation and what's different from the expectations. So you'll take what's different from the expectations and you'll write that into a test. And then the problem is to find the appropriate level for that test. Should it be at the class level? Should it be, well, a module level? Should it be, unit test, integration, whatever type of test? Sometimes it's obvious, sometimes it's not that obvious. So sometimes you'll need to write a test that is more like end-to-end or more covering a larger part of your system. Like maybe you need to call the service somehow, and you can decide to call with a curl call, or maybe you can go into the actual code and say, okay, we'll call this controller, this method from this controller, and see what happens with everything kind of plugged in. Sometimes it will be very obvious where to write, and then you're good. Then you change the test to the desired behavior, then fix the bug. And finally, you need to refactor. And here, when I refactor after fixing a bug in this way, there are two things I want to do. One of the things is probably to preserve this test that I wrote, or at least make sure that the behavior that I'm testing with this test will then be tested by other tests and remove the one. What's important is to make sure that you keep testing the behavior, because we want to avoid regressions. Bugs have some weird properties, and one of them is that they tend to reappear after a while. So because of that, we want to have tests that prove that will fail if the bug gets reintroduced, so that we don't make the same mistake again. And now at what level you need to write those? Ideally, you'd fit into your testing strategy, but sometimes it's not obvious. And in that case, it's maybe better to be safe than sorry and keep a separate test suite for bugs that were in the past. Maybe you tag them, maybe you annotate them somehow, and you have them in a separate suite that you can run together with the others. And these have they don't have the same rules. Like typically we want to organize tests based on their speed and their probability of failing, which is why we kind of separate micro tests and tests that hit multiple things. Like micro tests would hit only code and memory, and then you'll have other tests that hit the operating system, file systems, network, whatever, databases, data stores, other things. Typically we would do this. But for these types of tests with bugs, if it's not clear, I mean, sometimes a bug can be reintroduced from another place. I know it sounds weird, but it happens. So we might reintroduce the same bug by changing things in another place, and then it's good to have the test there at a higher level, even if the test is somehow duplicated at lower levels. Because sometimes the behavior will be split and you might make the same mistake in another place. And then you'll re-investigate the same bug, and that's a waste of time. So this is the thing. Now, why do we want to do this? Well, debugging is very slow, okay? Particularly when using a debugger, and with almost any other method, debugging is very slow. But one reason why I think many people do it, it's a lot of fun. It's like playing Sherlock Holmes. You get a mystery and you're trying to solve the mystery, and once you do, you feel good, because maybe the team will praise you. Maybe oh, we fixed that bug. It's a very nice feeling, honestly. But really, what's unfortunate for this feeling is that debugging is very slow, and it's better to prevent than to fix after the fact. And prevention is boring. well, it's not that boring for me, but in general, prevention is more boring than actually having fun, fixing the bug. Because prevention means doing code reviews, writing tests, doing pair programming, doing a lot of things. And while those things can be a lot of fun, and to me they are, the high that I had with debugging is not as high as what I have with the other things. Okay. So I can understand why we'd love to do some debugging. And occasionally, yeah, we need to. So we don't get rid of our mistakes that easily, but it is very slow, and we need to remember that. Now, another thing is this equivalence. When you attach a debugger and you start stepping into and doing a lot of operations, watching variables and so on, this is equivalent to an automated test that you don't keep. You can do exactly the same thing with a test. So what would be the equivalent? You would write a test that touches some lines of code, and you can limit, right? This is what you do with step over step, and you pick what to step into, and then you pick what variables to watch. The equivalent in tests is that you would pick a small piece of code to write a test upon. And how do you watch variables? Well, you verify their values at different points in time, right? It's as simple as that. So fundamentally, a debug session is an automated test, but the problem is attaching a debugger, going through, stepping into, doing all these things tends to be really slow, and you don't save this thing in order to be able to rerun it and recheck it. While with a test, you do. And so there's more left after you if you debug using tests. And those tests can be used to prevent regressions in the future, and they can also be used as inspiration for future problems that you might encounter. All right? So this is why, for time reasons, for effectiveness reasons, I prefer tests to debugging. But this doesn't mean that debuggers are not useful. So I'd like to make this very clear, because I had a few, I thought a little bit, actually I saw a post on Twitter, I think, somebody saying that, we've all learned programming by doing some debugging. And I think that's true, whether you did it with print lines or, printing out stuff after every line, or whether you did it using the debugger and going into code. Debuggers are incredibly useful because, particularly when you start learning a programming language and you don't really know how things work, what you can do is to take programs from the internet and kind of step into those and watch variables and see how they change. And this is incredibly useful for creating this connection between the static code and the dynamic behavior. This is something, it's a fundamental problem in programming. This is what we always do. We look at the code, we mentally translate into the dynamic behavior of the code, what it does at runtime. But what we have is static code. And the ability to do this is developed through practice. And when you start, you need some, practice wheels. And a very good practice wheel for beginner in programming is take a program, attach a debugger, start going through and carefully watch what changes and why and how. And this will help you figure out and create this connection in your head. And I think debuggers can be really useful when learning a new technology as well. Although I would argue that you can do the same thing with tests, okay? Another way of doing this learning is, and this is something that I've practiced with some people who wanted to learn programming. I think it's a very valid approach to teaching programming, and I think we should do this. Here's a method for helping people learn programming who are completely beginners. You show them how to write a test, which is fairly easy because it's a subset of the programming language. Then you discuss about a simple problem that you want to solve, adding two numbers, or I don't know, making a calculator or something like that. And you first write the test. First tests, if you are teaching somebody, it can be you who is writing them as an example, but then they can start writing the test, because the test will fundamentally be just a assert sum of 2 and 5 is 7, something like that. And then you let them write the code in whatever way they find natural. And then you start correcting and saying, okay, so what you're trying to do is good, but here's how the syntax works for this. And this is a way of learning programming which helps people see progress, because they keep seeing the green bar, you know. So we have a green bar, now we have a red bar. Okay, let's try to write some code. Oh, there's a green bar now, so I learned something new. And psychologically, it gets really, really nice from my experience. I had limited experience teaching with this method, but it worked really well. And I would love to see it applied more. And I believe that if we would start learning programming with a test-first approach, then really you would not have problems writing tests later on, and you will not complain about writing tests, because that's just the way you do it. Okay. The big problem is that we start learning in other ways, and then we are forced into writing tests, and then it's bad. So we talked about debugging and how it helps, and debuggers and how they help with learning. Let's now talk about the HouseMD method of debugging. This is a method of debugging that I have used for very complex bugs in the past. And it has always been really, really cool. Now, there are some caveats. One of them is that you need quite a lot of imagination. The way it worked for me is that I could somehow visualize the code, and I would look at the bug, and then I would say, oh, this is probably what is wrong with it. And sometimes the conclusion was wrong, but then, or was very far away. Sometimes it seemed very far-fetched. But I will go into one place, check one thing, and then know whether this is correct or not. And after I did that, if I found the bug, fine. If not, then I would say, oh, so maybe it's not that and it's something else. And I would go in the other place. And fairly quickly, I would find the bug. Okay. Now there's a more structured way of doing this, which you can see often in House MD if you watch the series, because they showcase this technique from medicine called differential diagnosis. So differential diagnosis is fundamentally this. You get a patient that has a particular problem, but in our case we'll talk about software that has a bug. And the bug is not obvious, right? We don't know where it's coming from. We are not sure. We are not sure why it happens, when it happens, all kinds of things. And the way differential diagnosis works is you first brainstorm a list of potential causes. Like maybe it's from that class not doing that, or maybe there are two processes that are not doing the right thing at the right time or whatever. And then you find ways to rule out some of the causes or to prove some others. And you basically go through the list and figure out, oh, this one, how can we rule it out or prove it? And usually you need to go do one thing and try that. Or you can try to prove, so either prove or disprove. Both are okay. Obviously, you try to find the cause, so if you can prove it from step one, that's perfect. But sometimes you need to rule out some other things before. So that's a matter of priorities. You will write that down and then figure out, okay, what's likely to happen here. Maybe we can rule this out like in 10 minutes. Let's just rule it out. And maybe you are surprised and that's the actual cause and you are done. Or you are not surprised and you rule it out and move to the next cause. Once you figure out what the cause is, the fix usually is trivial, except in some very specific cases when the fix is more complex. But typically, the bigger problem is to figure out the cause. And that's when this is powerful. If you already know the cause, but the fix is difficult, that's a whole other method you need to apply. Okay. I also have a story about the bug that I've been chasing. I think that was the worst, most annoying bug I had. It was in the beginning of my career. I was in Paris writing code for a product, for a startup there, and one of the... It was a C++ under Windows application, basically C++, MFC, and the application would run fine, but then occasionally just go away. Just, it would give a memory error and stop working. And these are the worst kind of bugs, the bugs that are intermittent. It happens sometimes, it didn't happen some other times. And it took me about 6 months to find the cause. And then the fix was just a very small change. And the problem was that so in MFC, you could write events, so answer to Windows events. But some of them were supported by the IDE, by Visual Studio. It would create them automatically, but other events you needed to take from the documentation and implement those. And yeah, it was make sure you're following all the rules. And I implemented one such event, which I don't remember what it was exactly, maybe something like a cursor entering a thing. Believe it or not, there was a time where in order to add a tooltip to a control, you needed to respond to an event. So might have been one of those. And what happened is that I allocated, so the parameter that I set, the type of one of the parameters was smaller in memory allocation than the actual parameter, the real value that we were getting. And so sometimes it just worked because the value was cast and it just fit the memory area, but sometimes it was bigger and it didn't fit the memory area. It would go overflow and boof, everything went down. And that's how we used to do programming. Now you can imagine that this, trying to debug something like this, oh boy, you can attach a debugger, and first of all, where do you start? Second of all, what's a possible cause for this? You know, I started noticing at some point that, you know, it was specific movements. I don't remember exactly. But basically it all clicked at one point when I looked at that method and I looked at the documentation and I was like, oh, it's unsigned int and it should be int or something like that. I don't remember exactly. I think it was int and it should have been long. Something like that. But yeah. And then the question would be, how do you test such things? Yeah, these are fairly difficult to test, right? But you can still send an event and try it out. But it's generally not something we can test, and it's something that we figure out how to solve through other means, like, you know, casting into the right thing or making sure the types. Personally, I like the Python way of types adapting to the value that they receive. That's what I would like to see, honestly. But anyway, this has been my story about bugs, about the worst bug I faced, and I finally managed to catch it. So, going back to our story, in conclusion, a few things you can do. Replace debugging with tests. Well, technically you can prevent bugs by writing tests appropriately. You need a good testing strategy. That's another topic. But in addition to that, you can also use, you can also debug with test first approach, which means when you get a bug, you first write a test that proves the bugs exist. Then you change the test to what you want the bug to be, the correct behavior to be, and then you change the code and then you refactor. Name the test such that you quickly find what's missing when a bug gets reported. That's very important. It's very helpful, and it's not something that you think about when you write tests, but really when you write a test, think about what would be the use of the test. I like to see the test failing because it will give me a view of what will happen when the test fails. But I also love to, actually in this process, I figure out what the name of the test should be and how it should report and so on. Because all those things are important when it matters the most. When you introduce a bug, tests are failing, you can figure out immediately why, what, where. Versus, or the other situation, you get a bug, you realize tests are missing, you know exactly what test to add because the test names are clear. That would be the ideal situation. Now we can get close to this ideal. We cannot get 100% of this ideal situation. Sometimes you'll need to investigate some more. And by the way, it's perfectly valid to write a test and then step into the test if you don't understand what's going on. So use the debuggers with the test. Anything you do to fix a bug quickly is worth it, right? So if you write a test that's on a high level that proves the bug exists, but you still can't figure out why and where it's happening, you can kind of step into the test and figure out what's going on. And then ideally you would write a more specific test that pinpoints the source of the bug with more accuracy. On the other hand, don't discourage people from using debuggers. No, don't shame people. The reason we are saying that we've not used a debugger in so much time is just because it's true, and it is a bit surprising for people who are not used with good test suites and with using tests in this way and so on. But it doesn't mean that we should never use a debugger. I mean, as I said, debuggers are incredible tools. They can do a lot of very, very useful things. And they work under a lot of different conditions. So you can definitely use a debugger to step through your code. Just try not to spend as much time there. Just for fun, and encourage beginners to look through a debugger. You should also encourage them to write tests because tests are easy to write, but encourage them to look through a debugger because it creates this connection between the static code and the dynamic behavior of the code. And finally, if you have any complex bugs where the cause is not clear, you can use differential diagnosis. I'm not saying always. I don't think it fits everybody. But for me, it was a very powerful way of solving bugs, and it worked extremely well. But I've noticed other people struggling with it, so I guess you need a lot of imagination. You need a way. You need to think outside the box a lot of times when you're doing this method. But really, if you're getting a lot of complex bugs, it's one of the best methods I know of figuring them out. And by the way, you can couple this with tests as well, because one way to rule out various causes is to write a test and prove that the test is working. Or maybe you can rule out a potential cause just because you have a test that proves that that is working. So it's really good to apply this method, I think. Okay, this has been all for today. I hope you found it interesting. Thank you very much for your likes. I see likes are continuing to come on our videos, which is great. We also love comments, so if you have any questions, if you have any comments, if you'd like to add from your experiences debugging or writing tests, or if there is anything that I missed, let us know in the comments and let's have a nice conversation. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next week.